Consider the given graph of f of x equal 3x to the third minus 2x squared minus 2x plus 2. So this is the blue graph. This is f of x. And the red graph here is f prime of x. F prime of x equal 9x squared minus 4x minus 2. So let's take a look at this graph. Note that when f of x is being positive, and let's call this interval here is a and b, or let this look like it's 0.5, so this is a negative 0.5, and this here is 1.5. So let's consider this graph here. Note that f of x is being positive, f prime of x is positive in the interval of negative infinity to negative 0.5. And you compare this with the graph of f of x, you can see that the graph f of x is increasing in the interval of negative infinity to negative 0.5. And note that here, at negative 0.5, f of x have a local max at x equal to negative 0.5. F of x has local max. And note that at x equal to negative 0.5, f prime of x is equal to 0. Okay. The other interval to consider is from negative 0.5 to 1.5. F prime of x is less than 0 from the interval negative 0.5 to 1.5. Then f of x, if you compare that, you can see that f of x is decreasing in the same interval. Okay. F prime of x is greater than 0 in the interval 1.5 to positive infinity, and note that f of x is increasing. Right? Suppose that f is the continuous function on the closed interval ab and differentiable on the open interval ab. F prime of x is greater than 0 for all x in AB, then f is increasing on AB. F prime of x is less than 0 for all x in AB, then f is decreasing on AB. Identify the interval in which the function is increasing and decreasing. So again, our first step is to find a critical value. So we want to evaluate. We want to find x such that f prime of x is equal to 0. So f prime of x equal to 4x to the third minus 12x squared plus ax. So f prime of x equal to 0. That implies 4x times x squared minus 3 plus 2, 3x plus 2 equal to 0. So 4x times x minus 2 times x minus 1 equal to 0. So x equal to 0 at 0, 1, and 2. So then we have 3 intervals to consider. We have 4 intervals to consider. We have interval from negative infinity to 0, from 1 to 2, from 0 to 1, from 1 to 2, and from 2 to infinity. And we will use the test value to evaluate f prime of x. And x equal negative 1, x equal 1 half, x equal 3 half, and x equal 3 in this case. And let's see what are the values of f prime of x. Okay. We can just find, we really don't care much about the value of f prime of x, but we care a lot about whether it is positive or negative. So we can accomplish that by using the factor of f prime of x. So f prime of x, here we have 4x, x minus 2, x minus 1, and here consider f prime of x. In the interval of x equal to negative infinity to 0, 4x here is negative. This will be negative, and this will be negative. So then f of x has been negative in this interval. Here we get negative, negative. Again, this is a negative, right? So again, f of x here being negative. But we look at 3/2. This is, this is positive here. So then this is positive. So positive, negative, positive. So this is negative, positive, positive, positive. So then this is positive. This concludes that f of x is increased in the interval 0, 1, union 2 to infinity. F of x is decreasing in the interval of negative infinity to 0, union with 1, 2. Take a look at the next one. Okay. So the interval in which this function is defined, we know that this interval, we have to consider the domain of this. This heavy domain is from 1 to infinity. Okay. So then first we find a critical value. F prime of x is equal 1 minus 3 divided by root of x minus 1. F prime of x equal to 0 with mean root of x minus 1 minus 3 divided by root of x minus 1 equal to 0. Root of x minus 1 minus 3 equal to 0. Root of x minus 1 equal 3. X minus 1 equal 9. This means x equal 10. The critical value, or the value in which f prime of x equal to 0 and f prime of x equal undefined. So the critical value here c equal 10 and c equal 1. So then we consider the interval for increasing and decreasing from 1 to 10 and from 10 to infinity. So f of x, we have f prime of x, we have we will consider this part of the function. Okay. So we have the numerator being square root of x minus 1 minus 3. The denominator being root of x minus 1. In the numerator, in the interval of 1 to 10, this root here will be negative. It will be positive, positive, positive. So then the f prime of x is being negative in the interval from 1 to 10 and positive from 10 to infinity. This means f of x is decreasing in the interval 1 to 10. Note that I don't include the value 1 here because this is undefined in our critical value. Okay. F of x is increasing from 10 to infinity. Actually, I take that back. 1 is in the domain of the function, so we do want to include that 1. First derivative test for local extrema. Yeah. Suppose that C is the critical point of a continuous function f, and that f is differentiable at every point in some interval contained in C except possibly at C itself, moving across this interval from left to right. If f prime change from negative to positive at C, change from negative to positive, which means f of x going from decreasing to increasing, then f have a local minimum. Right, it makes sense, right? If f prime change from positive to negative, then we have a local max. If f of prime x does not change its sign, then at f we have no extrema. Right? Identify the open interval in f, which f is increasing, decreasing, and find the function local, absolute extreme, and absolute extreme value. First, we need to take a look at the domain of this function. So in order for this function to be continuous or defined, 5x, 5 minus x have to be greater than or equal to 0. This means x have to be less than or equal to 5. So the domain of this function is from negative infinity to 5. So keep that in mind. So let's take a look at the critical value. So f prime of x is equal to 2x times root of 5 minus x plus negative x squared divided by 2 times root of 5 minus x. We will simplify this function. Find f prime of x equal to 0, and solving this function, we get f prime of x equal to 0 when x is equal to 0 and when x is equal to 4. Now we will find now that we have the critical value, note that we also need to find the interval in which it's increasing and decreasing, right? So let's go ahead and find the interval. We consider the interval from negative infinity to 0, from 0 to 4, and from 4 to 5. And we use the test value. I'll use x equal negative 1, x equal 1, and x equal to negative, and x equal to 4.5. And we will see whether f of x, f prime of x is positive or negative in that interval. When you plug this value into the function f prime of x, you see that f prime of x is negative in this interval, positive here and negative here. This means that f of x is increasing on the interval 0, 4. F of x is decreasing on the interval from negative infinity to 0, union with 4 to 5. So let's go ahead and try to find our extrema. So here we have a decreasing, and then we have an increasing and decreasing. So it may look like we have a min here, a max. And at x equals 5, somewhere here we have another min, whether it is local or is it that is a extrema. So let's evaluate the function f of x at this value to see. Okay. So what is the value of f? So the value of x when x equal to 0, when x equal to 4, and when x equal 5, f of x equals 0 square times root of 5 minus x. So then this equal to root 5, right? Excuse me, equal to 0. At 4, we have 4 square times root of 5 minus 4, that is 16. And here we have 5 square times root of 0. So this is 0. Okay. So note that here then we have a absolute max. Okay. We have an absolute max. Actually, because the function decreasing from negative infinity, here we have a local max. And we have two absolute mean. All right. Let's take a look at our next problem. F of x equal to negative 2x minus 2 divided by x squared minus 1 in the interval from 0 to 1. Let's first find our critical value. F prime of x is equal to x squared minus 1 minus x minus 2 times 2x divided by x squared minus 1 square. Simplify this, we get negative x squared plus 4x minus 1 divided by x squared minus 1. So the critical value here, f prime of x equal to 0. We will use quadratic formula to solve this. This gives us x equal to 2 plus or minus root 3. So then, the value, the critical value, in this case, x equal to 2 minus root 3, because that is in the interval from 0 to 1. So this is about 0.268. The next thing we do is we identify the increasing and decreasing interval. Again, we would divide the interval, the domain, into interval. So we will look at the interval from 0 to 2 minus root 3 and 2 minus root 3 to 1. F prime of x is being negative in this interval and positive in this interval. So here we have a decreasing and then increasing. So here we have some sort of min here. Okay. So let's evaluate this function. So we evaluate x at x equals 0 because we are including the point 0 in our interval, in our domain. So at x equal to 0, what happened to the value of f of x? F of 0 is equal to 2. And at 2 negative root 3, we plug that into our calculator and we should get the value that is about 1.866. So here, in this case, we have a absolute, because the function here is what increasing without bound. So here then we have a local max. Okay, in this case, a 2, and we have a absolute min. Let's consider the function f of x equals sine of x minus cosine of x in the interval from 0 to 2 pi. Now I will leave you to do this problem on your own. However, I will give you the answer here. F of x is increasing in the interval 0 to 3 pi over 4 union with 7 pi over 4 to 2 pi. F of x is decreasing in the interval of 3 pi over 4 to 7 pi over 4. And here are our extrema. In this problem, you have a local min at x equals 0, f of 0 equals negative 1. You have a local max at x equals 2 pi, f of 2 pi equals 1. You have an absolute min at x equals 3 pi over 4, f of 3 pi over 4 equal to, root 2. You get an absolute max. Oh, I switched your min and max. So this is your max. And this is min. At x equals 7 pi over 4. After 7 pi over 4, in this case, equal negative root 2.